Conic sections are interesting because they're actually parts of a cone. So if you were to take a cone, do my best to make a nice 3D drawing here. Okay, there we go. Thank you. I appreciate it. I practice. If you were to slice that a certain way, you get different shapes. Okay, so I know it's going to be difficult to kind of see some of these, and I am a true believer after spending a lot of time in mathematics that people's ability to have spatial reasoning and understand shapes it's incredible how different people are in that regard. So I'll do my best here. So I'm going to take like a knife. Okay, I don't have a knife. Don't be afraid. But I do. But I don't. I'm going to take a knife and I'm going to slice off the bottom here. Okay. If I slice off the bottom, can anybody see what kind of shape I'm going to get? A circle. Can you see that? Yep. Slice, I'm going to get a circle. Triangles? The top is a triangle. Good. Like a dunce hat. Yeah. Very good. Or a cone. Okay. So suppose I were to slice it differently. Suppose I were to slice it like that. Actually, let's go like that. I want you to look at the side of it. So suppose we pulled this side off, and you're looking at what remains. Do you know what shape that would be like? It would start kind of at a point here, wouldn't it? And then it would grow larger. Yeah, very good. It's a parabola. Can everybody see that? If you were to slice it like this, it would come to a point here, and then it would expand out on either side. Yeah, the sides of it, you get a parabola. Kind of neat, huh? So let's try another one. Let's slice it like that. Actually, you could look at this side or this side, either way. It's going to come to a point, and it's going to come out there, and you're going to get an oval. You're going to get an ellipse. And so you've seen that if you take a cone and you slice it different ways, you get different shapes. Now, you don't have to be able to regurgitate that, but what you do need to be able to understand is that the reason why they're called conic sections is because you could cut cones and come up with those shapes. But the definition for an ellipse is this: the set of all points whose distance from two foci sum to a constant. Now, I showed you the other day how I tried drawing a perfect parabola, right? And I will say I got my first one right in this class, but after that I started to not do a very good job. Okay? Taylor started making fun of me, which, that's okay. Sometimes your true nature comes through. It's all right. But I will say that then during third hour I didn't get any correct. So I was 1 for 6 that day. But you start to understand the definition of a parabola. Set of all points whose distance from the foci and the directrix is the same. So let's understand what the heck an ellipse really is. Well, that's really bad, huh? Yeah, that was give up right there. I mean, that was really bad. Okay, let's try again. Okay, not an ellipse, right? This is a circle, right? And would you agree that a circle is a set of all points whose distance from the center is the same? So like that distance there is the same as that distance there. That's how we define a circle. Everybody agreed? Okay. So suppose we were to change that and we did something like this. I wonder if I have an option for, oh, I do. That's kind of exciting. Whoa, look at that. Woo! All right. It's kind of, I've never used that before. Okay, so then what is an ellipse or an oval? So I'm not going to draw these perfectly, but instead of having a center, it has two focus points, focus point 1 and focus point 2. Let's not do that. Let's go back here. And if you pick any point on the ellipse, and you then look at the distance, and then pick another point on the ellipse, and look at those distances, we'll call this D1 and D2. We'll call this D3 and D4. It turns out that if you take D1 and add it to D2, you get exactly D3 plus D4. Again, you don't have to remember any of that, but I want you to understand what the definition means. Their distance from the two foci sum to the same. That's what it means. We can actually prove it, but we're not going to take that time. So let's go. Equation. We have x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. The center of your ellipse is going to be HK. How far do we stretch it? We look at the numbers underneath. See how it's x minus h squared? So this is my x stuff right here. It's stretched a units in the horizontal direction. So that would make this distance a. That would make this distance a. Anybody want to guess how far it's stretched in the vertical direction? B units, because B sits under Y. You see that? So let's start to talk a little bit about what these positions are. The vertices, we say, are these kind of endpoints out here. Vertice 1, vertice 2. And so if the ellipse is stretched horizontally, its vertices will be the h value, plus or minus the a value, and then k. So we'll go a units in each direction. The major axis is the distance from one vertice to the other vertice. Can somebody tell me the distance from one vertice to the other? 2a. The minor axis is the distance the other way. 2b, or not 2b. So far it's pretty easy to graph. What we want to do is we want to come up with the foci. The foci are located c units from the center on the major axis. So that distance there is c, and that distance there is c as well. So from our h value, we move plus or minus c values, and then k. Now you should have something going off in your brain right now. What's it saying to you? It's saying, what's c, right? Do you see a c up in your equation up there? I don't either. Turns out that you have a formula. A squared minus b squared is equal to c squared. Pretty close to the quadratic or the Pythagorean theorem, right? Except it's got a minus sign. And it's very important that if a squared minus b squared is c squared, it's very important that a squared is larger. So when you're trying to find out, you know, which one's A and which one's B, A has to be the larger of the two. Otherwise, you're going to get a negative. Okay? We good? Eccentricity is the measure of how stretched it is. And so the eccentricity is equal to your C value divided by your A value. And that measures how stretched it is. That's something that, when we talk about planetary motion, becomes rather important. Okay, so let's look at the vertical one. And the vertical one doesn't change very much. It's just x minus h quantity squared over b squared plus y minus k quantity squared over a squared is equal to 1. So what changed? Yeah, which one's longer? Yeah, because a now sits under the y value, right? And a is going to be the larger of the two. So you can see that our center is still HK. But what we're going to do is we are going to move A units vertically now instead of B units, because A is sitting under the Y value. So as we talk about our vertices, we will have H, and we have K plus or minus A. What is the length of that? 2A. How far do you think we go in the horizontal direction this time? We go B units each way for a total of 2B. And the foci stay the same. They are C units from the center, just like before. It's just that now they're on the, you know, they're stretched vertically. So we've got H, we've got K plus or minus C, and then your eccentricity is still C divided by A. So you've taken enough notes. Now you just want to see, you know, the application of one. What does this actually look like when we graph it? And I'm going to help you through that. Letter A. Is this stretched more horizontally or more vertically? Vertically. Why? Yeah. Yep. The A value is under the Y because 25 is larger. So I'm going to show you how to sketch this. They sketch so much more quickly than a parabola or anything else. You can make a graph. How many units does it stretch vertically in each direction? 5. How many units does it stretch horizontally in each direction? 2. That's pretty quick, isn't it? So let's identify the center, the vertices, the length of the major axis, the length of the minor axis, the foci, and the eccentricity. Where is this thing centered? 0, 0. The vertices on the top and bottom are side to side. Top and bottom. So I'm going to save some time here. Instead of writing 0, 5 and 0, negative 5, I'm going to write 0 plus or minus 5. Yes. Sure. We'll show you. Major axis. How far is it from up here to down there? 10. How far is it from side to side? 4. See, they're a little easier, aren't they, than parabolas? Foci, I got to determine what value for foci. C. C, señorita. So, my formula is a squared minus b squared is equal to c squared. What is a squared in this situation? 25 minus b squared? So 21 is c squared. So the root of 21 is equal to c, which is approximately like the root of 21. I'm guessing it's about 4.5, something like that. Do you agree? I'm just kind of getting a guesstimation here. So when I plot my foci, I'm going to move about 4.5 units. Do I move along the y-axis or the x-axis? The y-axis, yep. So it's going to be up there, down there. So 0, and then plus or minus the root of 21. The eccentricity, I take the c value, which is the root of 21, and I divide it by my a value. What is the a value? 5. The a value is the square root of the larger number. So I go ahead and I'm going to turn on my calculator. I'm going to take the square root of 21, which is, whoop, that was not even close. Try again. 4.58, so about 4.6. If I divide that by 5, I get 0.9165. The eccentricity value is always between 0 and 1. The closer it is to 1, the flatter the ellipse is, the more it looks like a line. And the closer it is to 0, the more it looks like a circle. So Jupiter's orbit might have an eccentricity of 0.76. I don't know. You could look it up. Have you ever been to Jupiter? Me neither. Look at how much we have in common. Okay, too easy. Let's make it more challenging. Next one. What makes this different? Doesn't have a denominator, not equal to 1. Has to be equal to 1. Put it in its appropriate form. How could I make it equal to 1? Divide by 36. Oh, didn't I pick nice numbers? 4 over 36 gives me x squared over 9. And 9y squared over 36 gives me y squared over 4 is equal to 1. Sweet. I love it. Do you love it, Morgan?
I love it.
Raise your hand if you're convinced. Anybody convinced? Oh, 2 laws convinced. Very good. It's okay. So like you guys took the AP Gov exam yesterday. Good for you. Way to do what's difficult. All right. I want to graph it. How many units does it stretch horizontally? 3. Vertically? 2. Now, I can draw it. And I'm going to come around and judge your drawing.
I haven't drawn it yet.
That looks pretty good. It kind of comes to a point there. Looks like a sideways teardrop to some degree. Whoa! Can I show? I'm. Yeah. Yikes! I got yikes. It looks like an onion. You're not an Oreo. Wow. Yo, some of you guys did a really good job. Wow. Okay. Let's identify the important characteristics. We've got center. We've got the vertices. The length of the major axis. The minor axis. The foci. And the eccentricity. Center is 0, 0. vertices. Plus or minus 3, 0. It's okay. Those are the mistakes that people make. Major axis. 6. Minor axis. 4. Foci. What do I have to find? A squared minus B squared. What's A squared? 9. So I'm coming up with the root of 5 is C. Everybody good with that? Which is like 2.24, right? Kind of committed that one to memory, right? Yep, good, good. I don't know, is it? I don't want to show off or anything, but what we got? 2.2. Well, it's kind of my job to know that stuff, right? Okay, so foci is going to be the square root of 5 units in each direction, 2.25. So that would be plus or minus the root of 5, 0. How do I calculate the eccentricity? Root of 5 divided by? 3. So if I take that 2.24 and I divide it by, whoa, where'd you go? Answer divided by 3, I get 0.745. Well, 0.75. You can tell that that one's not as stretched as the other one is it? So therefore, the value is getting closer to 0. These aren't as bad, are they? Let's do one where it's not centered at 0, 0, and we'll call it a day. I feel like we could just do letter A and be good. I don't think we need to do letter B. You guys okay with that? Let's try it. I'm going to go 6 by 6. 1, 2, 3, 4, 5, 6. Somebody tell me the center. Yep. Okay. Right here. Do you remember when we did, I feel bad every time I say that now. I will not say do you remember anymore. Back a while ago we did circles. And we did like x plus 4 quantity squared plus y minus 3 quantity squared is equal to, say, 25. And what you said is that circle has a center of -4, +3, and a radius of 5. That's what you said. And so you can see that this showed us the horizontal shift. This showed us the vertical shift. And so we've kind of been playing off that all year. And so sure enough, that tells us the horizontal shift, 3 units. That tells us the vertical shift. Did I do okay there? Okay, good. Try to meet you where you're at. All right. Yeah, it's crazy how math just... Every time somebody says I hate math, I'm like, oh, so you don't like to be logical. It makes sense. Anyway, so so we got a center of 3, 0. Can somebody tell me now I have the center, how many units do I move horizontally? 3. So from this spot, I move 3 units to the right and 3 units to the left. How many units will I move vertically? 1.
Where did we get the 1 from? 1 on the end or what?
So y squared over 1?
Oh.
So the vertices are these endpoints. What are those endpoints? Name them. 0, 0, and 6, 0. What's the length of the major axis? 6. What's the length of the minor axis? Those. Then we have foci and we have eccentricity. What do I need to find in order to determine foci and eccentricity? C. So I take a squared minus b squared. Or I'll put c squared. I'll put c squared over there. So we got 8 is equal to c squared. So c is equal to 2 roots of 2. You good with that? You know what the root of 2 is? 1.4, and we double that to get 2.8. So we're going to go 2.8 units in each direction. 1, 2, and 0.8. So as I moved 2.8 units in each direction, did I move horizontally or vertically? Horizontally. So is that going to change the x value or the y value of the center? X value. So the x value was 3, so it's going to be 3 plus or minus 2 roots of 2, and then 0. Somebody tell me, make a prediction about the eccentricity. Closer to 1, right? Because it looks really flat, right? So we take 2 roots of 2 and we divide it by what? 3. .94. And you can see that that's closer to 1, so we can see how flat that is. Now I'm saving this one. I don't think we need to go over it, but if we were too confused tomorrow, we could go over it. But now I want to show you kind of where we're headed. So that's the lecture for today. Let me pull. Oh,